And I would like. Okay. I would like to tell something about sanitation, disinfection methods of treated water. It's not working again. Yeah, it's working. The objective of sanitation is of course to reduce impotent and reduce or completely remove microbial contamination from the water, especially from treated water. The application of sanitation, the widespread, of course, is production of potable water, where all water should be somehow sanitated, and other areas are infected wastewaters, especially from mosquitoes. Very actual is combination with water reuse. One of them is also rainwater management and rainwater use, because also rainwater is somehow contaminated by microorganisms. Or there are some currently there's press to decrease the concentration of microbial contamination in discharged wastewater from wastewater treatment plant. Okay, wrong way. Okay. So generally methods. Then there is surely chlorination with using calcium chloride, using perchlorate bleach, using chloramines, and also modern method is the use of water dioxide, with the advantages without the water is without any byproducts. Ozonization is surely one of the most important and widely applicable methods. UV disinfection was mentioned. We also use this method in our treatment plant. Very nice is the method using peroxide compounds. I will show you some real application. And what is the case of our treatment plant is filtration by ultrafiltration, which is, as I mentioned before, barrier method of microbial contamination removal. Regarding chlorination, main advantage is that it is very easy to apply it. It's very cheap. The most important disadvantage is the formation of chlorine compounds, especially like trichlor, acetic acid, and other chlorinated compounds. So this is applicable for more for clean water, which is not contaminated by organic compounds. Ozonization is a very nice method. In the past was claimed that it's quite expensive. This is not really true. Here, these pictures are from our pilot sites here on wastewater treatment plant in Liberec. We use this method for final sanitation of water with combination with oxidation of resting micropollutants. Main advantages are that, as I mentioned, also some organic contaminants are oxidized, reduced. I mentioned this energy, but finally, the experience, especially from Swiss and from Germany, show that the real costs are main cost goes to energy, and this is only 0.3-0.5 kilowatt per cubic meter, which is not so big. There's also a risk when wastewater contains bromides. This could be oxidated to toxic bromides. contamination was UV disinfection, especially with UVC light. It's feasible, and main advantage is that we can apply it without any chemicals, just on the side. It is most important disadvantage is that cost effectiveness is lower, important low, because operational cost goes to energy, which and the consumption is really high. Maybe possible way, a potential way is application of LED sources. Filtration barrier. Here you can see director of the Liberec in our pilot. I mentioned before, we applied very dense ultrafiltration membranes. The pore size is less than 10 nanometers, so we are able to remove almost all microorganisms. Aerosol acids, as I mentioned before. Here you can see the picture is from Paris, from last Olympic Games, and Veolia, which operates the second largest wastewater treatment plant in Paris. This plant is for 2.5 million population equivalents. They applied this method for treatment, for replacing of microorganisms from the treated water to be able to cover water quality for swimming in just in the river. Regarding full-scale application of sanitation, one of them is through the central wastewater treatment plant in Prague. The capacity is more than 1 million person equivalent. There are finally some numbers also. Here you can see that the efficiency is pretty high for most pathogens, more than 90%. Here they applied UV tubes, which are submerged in the discharging canal, and by this way the water is sanitated. This is what I mentioned before, Paris, France, last Olympic Games. The very important advantage of this method is that the feasibility is very high. You don't need any investment cost. Everything goes to final chemical, which is formic acid and hydrogen peroxide. You need only a small mixing reactor for the preparation of final sanitated solution. This is similar from US. They applied peracetic acid. This is similar. The concentration is quite low. The first tens of milligram per liter are applied for sanitation. I mentioned that Switzerland is the leader in application of ozonation. This is primarily connected with removal of microorganisms, but of course ozonization is very effective also regarding sanitation of treated wastewater. Our experience, very briefly, in the frame of our Interreg project, Morris, following speaker Gregor Dill will inform you about all activities. Our role was remote management, remote harvesting and management. We are focused on rainwater sanitation because generally rainwater, especially from the roofs, is chemically clean, but is contaminated microbially, and I expect some numbers. No. Okay. Maybe here, no. Generally, we applied UV disinfection, and we have found that we are able to sanitate this water. UV is not stable procedure. So after some time, the water is again contaminated. But originally present pathogens are removed, and subsequently only let's say normal microorganisms can grow in this water. One thing I think is what I mentioned before. This is our pilot. Here is the unit for ozone production. The capacity is about 1 cubic meter, and here maybe you can see, or you can see later on, there are very strong decrease in microbial contamination. Also, we are focused on E. coli for total numbers, and we are able importantly decrease sometimes to zero the microbial contamination. Rainwater sanitation is what I mentioned before. Okay, wrong way. Water treatment is something what you will see tomorrow. There are numbers from some testing of other methods than ultrafiltration. It is also UV radiation, sodium hypochlorite, and here you can see what is important is absolute decrease of microbial contamination by ultrafiltration to almost zero. And thank you for your attention. I don't know how many times, no time it's
You have 3 minutes, I think.
3 minutes. Okay. So if you are interested, please, there is a space for comments or questions.
It's Paul Butters. Tomaš, I have a question for you. These are obviously very broad spectrum techniques. They kill all bacteria, microorganisms. In things like Swan Lake scenario that Peter was talking about, are there any approaches where maybe you focus on pathogens, and is there such a thing as helpful aquatic organisms that you would like to leave
there? Yes, it is one. Of course, always we apply somehow some biocide agent. So we have to be careful with chemicals. We can sanitate the water and then put the water back. What is one of the check pattern from Brno is here, plasma treatment by Caviplasma, and this is really what is already applied for some lake restoration. This is based on formation of cavity and plasma. Of course, the current production capacity is about 4 cubic meter per hour. This is maximum capacity. What is useful that by these techniques you can produce water with resting concentration of hydrogen peroxide. So, but it is always the question of the final concentration, because of course we can impact everything in the lake. So, but this kind of techniques based on UV methods, also this method are really good because no chemicals are added, and the products of oxidation are subsequently very quickly removed, like the rest of ozone, rest of hydrogen peroxide. But always we have to be careful about the application.
I just thought it was quite worth pointing out that maybe the system where you have the wetlands as well in this project means that you will have removed harmful organisms, but maybe by the time the water comes out of the wetland, you have a correct microbial ecosystem in the water.
This is what we discussed before we got going on that after wetland, we have found much more lower concentration of pathogenic microorganisms. So wetland generally itself, based on the type of operation, is a type of wetland, you can importantly also reduce the concentration of pathogens.
I also have a question about phosphate. I'll ask you that over lunch. Peter.